Okay, on 28, I'm back to implicit differentiation here. So the derivative of cosine is negative sine. I'm going to keep the 3, that's my constant, and use the chain rule right here. So the derivative of sine is cosine. I'm going to leave my 2y the way that it is, and then I'm going to multiply by the derivative of the inside, which is 2, and don't forget your dy dx, since we're taking the derivative of y, and then the derivative of 5 is 0. Okay, I'd like to get dy dx by itself, so let's start by adding the sign over to this side. And I'm going to go ahead and multiply my 3 times my 2 as well, so that'll give me 6 times the cosine of 2y, dy over dx, and I'm going to add that sign over to the other side. Now, these are held together with multiplication. I'm trying to get this by itself, so I can just divide over, and that's going to leave me with the sine of x over 6 times the cosine of 2y. Okay, on number 29, they've given me the derivative already, and they're asking me to find the second derivative. So the first derivative that they have given us is 5x over 3x plus 4y. So not only are we taking a second derivative, we also have to use the quotient rule. So that right there is the symbol for a second derivative. Okay, so when I go to use my quotient rule, I'm going to label the numerator as f and the denominator as g, and I'm going to start with g times f prime, so the derivative of 5x is 5, minus f times g prime, so the derivative of 3x is 3, and the derivative of 4y is 4, and don't forget your dy over dx. And then I'm going to divide that by g squared. I'm going to keep dragging that g squared along with us as we go. So g f prime minus f g prime, and then all over g squared down there on the bottom. All right, let's distribute in our 5, so that's going to give me 15x plus 20y, and then I'm going to have minus 15x when I distribute into here, and then I'm going to have minus 20x dy over dx, all divided by still my 3x plus 4y squared. At this point, I'm going to keep dragging that along for a while. Alright, I'm going to let my 15x's cancel out at this point. I don't need to keep working with those. And so now I'm also going to do one more thing. I'm going to replace this with what I know dy dx is equal to up here at the top. So I'm going to have 20y minus 20x times 5x over 3x plus 4y. Okay, let's do a little bit of multiplying with what we have right here. So I'm going to keep my 20y, and now I'm going to have 100x squared on the top, on the bottom 3x plus 4y, and now I'm going to put those fractions together that I have up there on the top. I don't want to use keep it, change it, flip it, or multiply by the reciprocal until I have one fraction all together up here on the top. So I'm going to put these together, and I'm going to use smile to do that, or find a common denominator. So multiplying those together is going to give me 60xy, and then this is going to give me 80, plus 80y squared minus, from this minus sign right here, and then multiply these together gives me 100x squared, and then smile on the bottom is going to give me 3x plus 4y. Now I'm going to go ahead and at the same time multiply by the reciprocal of this, which is 1 over 3x plus 4y squared. Okay, so on the top now, nothing's going to cancel out with that. I'm just going to leave that the way that it is. So that's going to give me 60xy plus 80y squared minus 100x squared. And on the bottom, I'll have my 3x plus 4y cubed. So there's my second derivative right there. Okay, on number 30, I am working with some increasing and decreasing. So when we see that, I know that I want to find the first derivative. Okay, so the first derivative of this thing, if I bring down my 3, that's going to give me x squared minus 2x minus 3, and the derivative of the 2 will give me 0. Okay, so for increasing and decreasing, I want to find out where this thing is changing from positive to negative. So first, I want to know where the first derivative is equal to 0. That'll give me my critical points. So my first derivative, x squared minus 2x minus 3 is equal to 0 when I factor this. So that'll give me x and 3 and 1, and I'm going to need a negative 3 and a positive 1. So my two zeros are going to be at 3 and negative 1. Okay, so let's start by getting those on my number line. So negative 1 and positive 3. All right, now I want to know where my first derivative is positive and negative. So I'm going to plug into my first derivative, and I'm going to do that right here in the factored form because that'll be the easiest place to find out positives and negatives. So this would give me negative 5 if I plug in negative 2. So negative 5 is negative times negative 1 is negative. So all of that together is positive. So anything less than 1, the first derivative is going to be positive. All right, 0 is an easy thing to plug in between them, so that'll give me negative 3 and positive 1. That's a negative. And I'm going to pick anything greater than 3, so let's say 4. That'll give me 1, which is positive, and 5, which is positive. So everything above 3 will be positive. So there's increasing and decreasing and increasing for my function. So this is what's happening with f prime, and on the bottom I have what's happening with my function. Okay, so my function is increasing from negative infinity to negative 1 and from 3 to infinity, and it asks me to justify my answer, so because f prime is positive. Okay, then I know that my function is decreasing from negative 1 to 3 because f prime is negative. Okay, and then finally it asks me about a maximum and a minimum point. So if I draw a little picture of what my graph might look like, increasing and then decreasing and then increasing, I notice that right here I make a maximum point, so that will happen where x is equal to negative 1 because f prime changes from positive to negative. And then I have a minimum point where x is equal to 3 for the opposite reason, because f prime changes from negative to positive. And notice that on all of those, my justifications talked about f prime. That right there is very important. Okay, on number 31, we're talking about concavity. So when I talk about concavity, I want to think about my second derivative. Let's get f on there first. So my f, my function here, is 1/2 x to the 4th plus 2x cubed. So the first derivative is going to give me half of 4, which is 2x cubed plus 6x squared. So the second derivative then is going to be 6x squared plus 12x. And very much like what we did above, the first thing I want to know is where it's changing from positive to negative, or where the second derivative is equal to 0. That's going to give me my points of inflection. All right, so 6x squared plus 12x is equal to 0. I'm going to take out a 6x as a common factor. That's going to leave me with x plus 2. So that's going to tell me that x is equal to 0 and x is equal to negative 2. Okay, so on my number line, negative 2 and 0. And I want to pick numbers, so let's start with negative 3. And again, I'm going to plug into my factored form right here. You can plug into the original second derivative if you want to. This right here is very easy to use. So that's going to give me negative 18 and negative 1, which gives me a positive. And in between, I'm going to use -1, so that'll give me -6 times +1, which gives me a negative. And up here, I'm going to use 1, so that gives me a +6 and a +3, which is positive. And so here we have concave up, and concave down, and concave up. Okay, so my graph is concave up from -infinity to -2, and from 0 to infinity, because f double prime is positive. And my graph is concave down from -2 to 0, because f double prime is negative. And then we have inflection points, or points of inflection, where x is equal to -2 and where x is equal to 0, because f double prime is changing from positive to negative, or vice versa. Okay, on the next video we'll pick up with number 32.